So when I am talking about positive condition, the current will go like this. Oh yeah, this is my forward bias, so the circuit will be completed. The circuit will be completed. So if I draw the output voltage, if I draw the output voltage V out, okay, with respect to time, you will say that if my input is like this, if my so now what is actually the use? Okay, and people said that this PN junction diode is useful. This is useful. So how is this useful? Do we have real life application of this? Definitely yes. Okay, what is the real life application? So I will begin one by one. The first application that I want you to know is half wave rectifier. Half wave rectifier. Now what is this half wave rectifier? Half wave rectifier. If I am talking about a circuit, in that circuit I am talking about wave. Where in a circuit do I find wave? When I find them in case of AC current, remember alternating current. So basically half wave rectifier are used to convert, they are used to convert the AC into DC. The AC into DC, but that DC is basically useless to us. That DC is basically useless to us. Okay, what does this mean? Hear it out carefully. Okay, what does this mean? So in a half wave rectifier, we are having a circuit like this. Okay, the circuit is something like this. Okay, so this is my output, this is my output. The potential difference across this will be V, and this will be known as V output, and this is basically my V input. Okay, my V input will be variable. I'm talking very openly that this EMF will be variable here. Okay, why? Because you can see that this is from an AC source, alternating source, and if I just for my convenience I take it to do a sinusoidal function, I can have the voltages like this. Okay, the voltage is something like this. Okay, therefore the current that has been produced is also like this. The current that will be produced here will be also like this. Okay, let us say that here the current is positive. Okay, positive current means the current is flowing like this. Okay, and negative current means current is flowing like this. So when I am talking about positive condition, the current will go like this. Oh yeah, this is my forward bias, so the circuit will be completed. The circuit will be completed. So if I draw the output voltage, V out, okay, with respect to time, you will say that if my input is like this, if my V input with respect to time is like this, okay, you will find from here that for the first one V is like this, V output is like this. Okay, but as soon as the voltage switch is same, the voltage switch its sign, it changes its direction and goes in the reverse direction, the current will start going like this, and as soon as it will go like this, it will find that oh, it is a reverse bias condition, I cannot flow here, therefore the current will become constant, the voltage output or the current output becomes constant. Okay, for the next wave which is in positive direction, it will be again here like this. Next one it is like this. Okay, again it is like this, and in this way the current keep on changing, sorry, the voltage output keep on changing. Okay, remember what was DC current? DC current was a current which could have the variable magnitude, but the direction is a constant. The direction is a constant, it should be in the same direction. So yeah, this is in the same direction. Okay, I am having all my output voltage in a single direction. Therefore what I observe from here, that though my input voltage, though my input current or my input voltage is an AC, okay, the output is DC. The output here is equal to DC. Is that clear, guys? You got it? Okay, another thing, can I say that here the output frequency, the output ripple frequency, okay, the frequency of change of voltage, this is equal to the input frequency, the input frequency. How can I say this? Just have a look. Okay, here if for this I am having this, okay, but for this I am having this, it means a single cycle is like this. This is my single cycle, and that single cycle will be of the same time period as usual. Okay, I hope you understood this. Okay, if you got it, then yeah, you have got the right one. Okay, now this is known as half wave rectifier. Now you can know the significance of the topic. Okay, why I have said that this is a half wave rectifier? Well, I said that this is a half wave rectifier because it rectifies, it converts only the half wave. Only the half wave is solved here. Okay, so yeah, this was my half wave rectifier. So what is the value of the current over here? Okay, well, can I say here that what is the average voltage? Okay, so if I find the average current, okay, what is the average current for a half cycle? For a half cycle, the value of the average current is 2 mu naught upon pi. Sorry, 2 I naught upon pi. Getting it? What is the value of the RMS value of the current for a half cycle? The value of the RMS current of the half cycle is equal to I naught by root 2. Okay, since I am having only the half amount over here, I will say that the value of the output current, okay, you can say from here that for output current for full cycle, why I'm taking full cycle, because I'm talking about this plus this, I'm talking about this plus this. Okay, the value of the output current for the full cycle, this is equal to I naught upon pi, because right now I talked about this for a half cycle. Okay, the time period was half over here. Okay, the time period was half over here, but here the time period is about the full cycle, so it will be the same. The value will be I naught upon pi. Okay, that is derived from the half cycle, but the value will be doubled over here, which is equal to I naught upon I naught by pi. Is that clear, guys? Okay, and what about the RMS current? So you can find from the RMS value of the current that the value of the output, okay, for full cycle of the RMS, this is equal to, yeah, remember this was average value. Okay, for the RMS current, this is equal to I naught upon 2. Why it is I naught upon 2? Because the virtual current is getting half to its value. Okay, because half cycle is not completed. Okay, half cycle is a constant. Okay, these are not usually asked in your theory question, but yeah, these were asked in your this can be asked in just a form of MCQ, so please note it down. Okay, so if I repeat it again, what is the half wave rectifier? As the name suggests, it is a rectifier. Rectifier means something which is not good for us, it is just converting it out. So we were having the AC current, that AC current could damage our applications, the appliances that we use in our houses, therefore it needs to be converted into DC. So to convert AC to DC, that is done by the rectifier. Okay, so yeah, this was our rectifier. Now you can see that here the input current was in the sinusoidal function like this, but since I am using a single diode here, so when the current will be flowing through one direction, for one direction it could be forward bias, but when the direction of the current will be reverse, that time it will behave like reverse bias. Okay, so half wave is obtained and the other half voltage wave is not obtained over here. Okay, this is the output that is just visible to you. Is that clear? Okay, the most important thing that is being asked, okay, the most important thing which I feel that is being actually asked, and that is very important for you, that the frequency remains the same. The frequency remains the same. Is that clear, everyone? The frequency remains the same. So yeah, we discussed about the half wave rectifier. Now let us discuss about a full wave rectifier. So can you make a guess that what does a full wave rectifier do? Well, the full wave rectifier will convert the whole voltage. Okay, it will just convert the whole voltage, or you can say that whatever will be input, the same will be output. Okay, let us check. So if I write what is the function of the full wave rectifier, basically the function is same, converts AC current to DC current, simple. Okay, well, if in a full wave rectifier I use a half, if in a half wave rectifier I have used one diode, so for a full wave rectifier, can I use two diode? Okay, if you place two diodes like this, okay, it will be same as the half wave rectifier, right? Okay, let me draw it for your reference, that if I place the current like this, okay, if I place it like this, it is of no use, okay, because this will behave like a single one. Okay, but if instead I make it something like this, okay, this is not used at all. Okay, but if instead I make it something like this, okay, I am making it something like this. Okay, what is the thing you will be observing from here? Well, you will observe from here that for the first condition, okay, for the first condition, let us say my input current is like this. Okay, if I say that this is the positive direction and this is the negative direction, so for the first one, the current will go here, forward bias, tick, reverse bias. Okay, note it. For the next one, now it is forward bias here, tick. Oh, it is reverse bias here. Note it. The current will not flow here. So therefore, if you plot the graph for the output voltage will be a constant, that is 0. The output voltage will be 0 overall. Okay. So yeah, the thing that I wanted to rectifier has been done. Okay, but the output voltage, okay, the output is always 0. The output is always 0. Therefore, it is not a rectifier. I cannot call it a perfect rectifier. Okay. What if I do something like this? Okay, what if I do the same thing, the same way I have done here? Okay, I am using like this. Okay, so here you will find that if the current goes through like this, forward bias, continue, check. But if the direction of the current is reverse bias, not check, reverse bias, not check. No. So what is happening over here? This is behaving like a half wave rectifier only. Both of these behaves like a half wave rectifier only. But what do I want? I want full wave rectifier. So what is suggested to you? You have to use two diodes parallel to each other. You have to use the two diodes and then parallel to each other. Okay, so if I take them parallel to each other, that means if this is my, let's say, voltage, okay, so yeah, this is the first diode, okay, this is the second diode, okay, they are placed parallel to each other, and they are in a continuous fashion as well. Okay, so if the current flows from here, reverse bias no, forward bias yes, entire current will go here. Okay, the output, the V output is nothing present over here. Okay, what if I take the second condition? If the current goes like this, current forward bias check, it will not go to the other circuit, it will simply cross it like this. So the output voltage here is constantly zero. The output voltage is constantly zero. Therefore, this is not a rectifier. This is not a rectifier. Okay, so okay, I understood that I have to take them in series, but I have to take it in some different fashion. Okay, do not connect the resistance in parallel, connect the resistance in series with the circuit. So finally, I got this thing. Okay, this is my output voltage, this is my input AC, okay, and this is like this. Okay, I hope you are getting it, that this is my output voltage, this is my input, if this is my T1, and if this is my T2. So let us say that for the first time the current is going like this. Oh, forward bias, continue. For this one, if the current goes from the above section, if it goes from the above section, forward bias check. For this one, reverse bias not check. I have nothing to do with this. Entire current will go from the above section. Okay, it will continue over here. Okay, so first thing that I wanted to do is done. What if the direction of the current changes? No problem. Let us say that the current is going through this way. Okay, first it goes from the above section. Oh, reverse bias, I can't go from here. No problem, the lower section is left. Oh, forward bias, done. The current will go from here to like this. Okay, so what is being observed from here? What is the thing you will finally conclude from this? So if I say that my input voltage is like this, okay, if I say that the voltage input is something like this, so what is the thing I get in the output voltage? So in case of output voltage, I will find the same variability. The magnitude of the voltage will keep on fluctuating the same way. The magnitude of that will keep on fluctuating the same way, but the direction will now be completely positive. Okay, though we have find that the direction was changing, but the voltage direction of the output voltage is not changed at all. Okay, this is the output that you get from here. I know I'm repeating it a lot of time, but I hope that is clear to you. Okay, so yeah, I can say that this is my full wave rectifier. This is full wave rectifier. Okay, that has converted, just a minute, rectifier. Okay, and the function that I wanted to get is that it has converted AC into DC current. Got it. Okay, what is the output frequency here? What can I talk about the output frequency? So output frequency is equal to 2 times of the input frequency. The output frequency is equal to 2 times of the input frequency. Are you getting it? The output frequency is basically 2 times of the input frequency. How can I say this? How is this possible? Okay, earlier for a full cycle I was having the peak value at 2 times, but that too were in the negative direction. Now I am getting it in the same direction. So yes, I can say that this is having 2 times of the frequency as earlier. Okay, and as I mentioned that this is something which can be called as most important here. So please note it somewhere. Okay, so fine, I got it that how to make it, but like how will I actually use this? Well, using this is also so simple. Okay, what you have to do, you can take a transformer. Okay, now but remember, okay, I cannot completely say that this is a full wave rectifier which is very functional. Okay, this is also useless. Why this is useless? Because you can see from here that the voltage is constantly changing. Therefore this full wave rectifier is still a useless. Okay, it is having no significance over here. Then how to actually resolve the problem? I want that my input voltage is like this, but my output voltage is this. It is a constant thing, and that in the same direction. It is simple. How you can do this? Basically, here in this condition, if I am placing a transformer, here, because a transformer is the one from which we will get it. If I say that this is my first diode, and if I say that this is my second diode, okay, and what I found from here, that here the resistance was placed like this. Okay, so yeah, this was the thing I was finally finding from here, that this is my D1, this is my D2. Okay, let us say that the input current has been here like this. Okay, so here first time current will pass through here. Okay, it will complete the circuit, and for the next moment the current will pass through here. Okay, and it will complete the circuit. I got it. But what is the output here? The output is something like this. Which is not good at all. Okay, so scientists found a good way to this. Okay, that you can use a capacitive filter. Okay, what is a capacitive filter? Remember that I once told that capacitor are the one, okay, because we have already studied the topic of capacitor. So capacitors are the one that are used to store the energy, okay. Capacitors store the energy, and once the potential difference across them is removed, the capacitor will now radiate the charge. When the charge is radiated, current is radiated, or you can say voltage is being created, okay. So what you have to do instead of this, take the transformer. This is my transformer, okay, and this is my household circuit, let us say, okay. This is my diode, okay, fine, and this is my resistor, across the resistor place a capacitor, mind it very clearly, okay. Across the resistor you have to place a capacitor, okay. And yeah, the circuit is now done, okay. Let us say that my input voltage is like this, fluctuating, okay. Now what is happening over here? Let us say that in the first time the current is going through this way, so the current will come on over here, okay. Now it will pass through the resistor, and some amount of current will also go through the capacitor. The capacitor will charge. So when the peak is increasing, okay, when the peak of the voltage is increasing, so what is happening over here? Hear it out carefully, okay. When the peak of the current is increasing, so I can say that the capacitor is getting charged, okay. And you can see that here the current will be something like this, the output current is something like this, okay. Now as soon as the output voltage will decrease, try to decrease, so the amount of current was trying to decrease from here, but the capacitor now got discharged, and it started to give its own current over here. The current that was getting decreased by the source, the capacitor added to the current, and somehow managed this. In the second time, now when the current will be passing through this way, okay, the same story will repeat, and overall I will say that the output voltage is somewhat managed. Over here, okay. So earlier you were having the graph like this, the input graph was like this. Though it was a DC current, it was in the same direction, but the magnitude fluctuated very large. Now due to the capacitive filter, that is adding a capacitor in parallel to the resistor, to the output resistor, I got the graph like this, okay. It almost tend to be stable, okay. Is that clear, everyone? Have you understood this? Okay.
It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.